Bismillahirrahmanirrahim. Welcome, guys. The topic for today is periodic motion. We are not going to study periodic motion a lot, but our main topic is simple harmonic motion. But before going to the main topic, I would like you guys to know about periodic motion as well. So, periodic motion. The periodic motion is the motion of an object that regularly returns to a given position after a fixed interval time. So, example of the periodic motion: the Earth returns to the same position in its orbit around the Sun each year, resulting in the variation among 4 seasons. ठीक है? Did you know the London Millennium Bridge over the River Thames in London? On the opening day of the bridge, pedestrians noticed a swinging motion of the bridge, leading to its being named as the Wobbly Bridge. The bridge was closed after 2 days and remained closed for 2 years. What is simple harmonic motion? A special kind of periodic motion occurs in mechanical system when the force acting on an object is proportional to the position of the object relative to some equilibrium position. If this force is always towards the equilibrium position, the motion is called simple harmonic motion. So, motion of an object attached to the mass spring when the spring is neither stretched nor compressed. The block is at the rest position, called equilibrium position of the system. We know from the experience such a system oscillates back and forth if disturbed from its equilibrium position. When the block is placed to a position X, the spring exerts on the block a force that is proportional to the position that is given by the Hooke's law. F is equal to minus kx. We call that F as the restoring force because it is always directed towards the equilibrium position, and therefore the opposite of the displacement of the block from equilibrium. That is, when the block is displaced to the right of x is equal to 0, the position is positive. The restoring force is directed toward the left. When the block is displaced to the left of x is equal to 2. इसका मतलब ये है ना, देखें कि इक्विलिब्रियम पोजीशन 0 है. फर्ज कर लेते हैं अगर उसको आप राइट साइड पे खींचते हैं ना, ठीक है, उसको डिस्टर्ब करते हैं, तो ये जो रिस्टोरिंग फोर्स होगी वो टू द लेफ्ट होगी, और अगर आप लेफ्ट पे उसको करते हैं तो रिस्टोरिंग फोर्स जो होगी वो राइट पर रहेगी, इक्विलिब्रियम पोजीशन की तरफ हमेशा रहेगी वो. अब देखें, ये इस डायग्राम से बिल्कुल क्लियर हो जाएगा. जब आपने ब्लॉक को डिस्प्लेस किया टू द राइट ऑफ इक्विलिब्रियम, तो फोर्स जो स्प्रिंग ने लगाई वो इक्विलिब्रियम पोजीशन की तरफ थी, और इक्विलिब्रियम पोजीशन पे पहुंच के उसकी फोर्स क्या हो गई? 0 है. ठीक है, जब इक्विलिब्रियम पोजीशन पर ब्लॉक है ना, तो उसकी फोर्स 0 रहेगी. अब ब्लॉक लेफ्ट पर है, ठीक है, ब्लॉक लेफ्ट पर आपने उसको कर दिया, और फोर्स किधर जा रही है? फोर्स अब वो उस तरफ लगेगी, इक्विलिब्रियम पोजीशन की तरफ जाएगी. ठीक है ना, तो देखते हैं आगे. अब when the block is displaced from the equilibrium point and released, जब आप ब्लॉक को डिस्प्लेस करें और रिलीज कर दें, it is a particle under a net force and consequently undergoes acceleration. Applying the particle under a net force model to the motion of the block. तो net force model जो आपने पढ़ा हुआ है, EFX is equal to MAX. ठीक है, तो is equal to minus kx is equal to ma. This implies the minus kx is equal to ma. A is equal to minus k by m into x. The acceleration of the block is proportional to its position. The direction of the acceleration is opposite the direction of the displacement of the block from equilibrium. Systems that behave in this way are said to exhibit simple harmonic motion. An object moves with simple harmonic motion whenever its acceleration is proportional to its position and is oppositely directed to the displacement from equilibrium. Thank you. That's it for today, guys.